And in this lecture, I'm going to give a little overview and a very brief history of the R statistical programming environment. So the very first question I think is most obvious, which is what is R? And the answer is actually quite simple. It's basically R is a dialect of S. Okay, so that leads to the next logical question, which is what is S? So S was a language, or is a language, that was developed by John Chambers and at the now defunct Bell Labs. And it was initiated in 1976 as an internal statistical analysis environment, so an environment that the people at Bell Labs could use to analyze data. And initially it was implemented as a series of Fortran libraries to kind of implement routines that were tedious to have to do over and over again, so there were Fortran libraries to repeat these statistical routines. Early versions of the language did not contain functions for statistical modeling. That did not come until roughly version 3 of the language. So in 1988, the system was rewritten in the C language and to make it more portable across systems, and it began to resemble the system that we have today. So this was version 3, and there was a seminal book called The Statistical Models in S, written by John Chambers and Trevor Hasty, sometimes referred to as the White Book. And that documents all the statistical analysis functionality that came into that version of the language. Version 4 of the S language was released in 1998, and it's the version that we more or less use today. The book Programming with Data, which is a reference for this course, is written by John Chambers, sometimes called the Green Book, and it documents version 4 of the S language. So R is an implementation of the S language that was originally developed in Bell Labs. So just a little bit more history here. In 1993, Bell Labs gave a corporation called StatSci, which became Insightful Corporation, an exclusive license to develop and sell the S language. In 2004, Insightful purchased the S language completely from Lucent. So Bell Labs became Lucent Technology for $2 million and became the current owner. In 2006, Alcatel purchased Lucent Technologies, and it's now called Alcatel-Lucent. So Insightful developed a product which was an implementation of the S language under the product name S+, and it built a number of fancy features into it, for example, graphical user interfaces and all kinds of nice tools. And that's where the plus comes from in S+. In 2008, Insightful Corporation was acquired by a company called Tibco for $25 million, and that's more or less where it stands. Tibco still develops S+, although in a variety of different types of business analytic type products, and it continues to this day. So you can see the history of the language is a little bit tortured because of the various corporate acquisitions, but it still survives to this day. The basic fundamentals of the S language have not really changed since 1998, and the language that existed in 1998 looks more or less like what we use today, at least superficially. And it's worth noting that in 1998, the S language won the Association for Computing Machinery's Software System Award, a very prestigious honor. So in a document called The Stages in the Evolution of S, John Chambers, who was the original writer of the S language, the original creator, kind of laid out his key principle with designing the S language. And it's very important, I think, to see this, which is that basically they wanted to create an interactive environment where you didn't have to think of themselves as programming, right? Then he says, then as the needs became clearer and their sophistication increased, that you should be able to slide gradually into programming when the language and system aspects would become more important. So the basic idea is behind the S language and then later the R language is that people would enter the language in an interactive environment where they could use the environment without knowing about any sort of programming or without having to know very detailed aspects of the language. So they could use the environment to look at data, to do basic analyses, and then when they kind of outgrew their environment, then they could get into programming. They could get into learning the language aspects and learning to develop their own tools, and the system would would promote the kind of transition from user to programmer. And so that was the basic philosophy of the S language. So that's enough about S. Let's go back to R. So what is R about? So basically R is a relatively recent development. In 1991, it was created in New Zealand by two gentlemen named Rossi Haka and Robert Gentleman. And they talked about their experience developing R in a paper published in 1996 in the Journal of Computational and Graphical Statistics. In 1993, the first announcement of R was made to the public. In 1995, Martin Meckler convinced Ross and Robert to license R under the GNU General Public License. And we'll talk a little bit more about that in a second. And that made R what we call free software. In 1996, a mailing list was developed. So there's two main mailing lists. One called R Help, which is a general mailing list for questions, and R Devel, which is a more specific mailing list for people who are doing development work in R. In 1997, what's called the R core group was formed, and this contained a lot of the same people from the S Plus who developed S Plus, and the core group basically controls the source code for R. So for the primary source code for R can only be modified by members of the R core group. However, a number of people who are not in the core group have suggested changes to R, and they have been accepted by the core group. So some of the features of R, the first one, which was important kind of back in the old days when people were still using S+, but the syntax is very similar to S, which made it easy for S+ users to switch over. This feature isn't quite so relevant today, where most people generally go to R directly. The semantics are superficially similar to S, in that it looks like it's S, but in reality are quite different, so we'll talk more about this in a future lecture. One of the main benefits of R is that it runs on pretty much any standard computing platform or operating system. Mac, Windows, Linux, whatever you want, even on your PlayStation 3. And there are frequent releases, so there are annual major releases, and often there are bug fix releases in between. So there's very active development going on, and so things are happening. The core software of R is actually quite lean. Its functionality is divided into modular packages, so you don't have to download and install a massive piece of software, whereas you can download a very small piece of fundamental core kind of functions and then add things on as you need them. So its graphics capabilities are very sophisticated and give the user a lot of control over how graphics are created, and in my opinion are better than most stat packages. It might even be the best for kind of a general purpose statistical package. It's very useful for interactive work, as I said before, but it contains this powerful programming language for developing new tools, so it eases the transition from the user to the programmer. And fundamentally, actually, for a language like this, is that there's a very active and vibrant user community. So the mailing lists like R Help and R Devel are very active. There's many posts per day, and there's also a series on Stack Overflow where questions can be answered. So the user community is one of the most interesting aspects of R. It's where all the R packages come from, and it creates a lot of kind of interesting features. Of course, probably the most critical feature of R is that it's free, both in the sense of free beer and the sense of speech. So what I mean by that is that it doesn't cost any money, so you can download the entire software from the web, and also it's free software. So I'm going to divert for a second to talk a little bit about free software. So with free software, there are four basic principles, right? You have four basic freedoms that you have. The freedom 0 is the freedom to run the program for any purpose. So there's no restrictions on how you can run the program or when you can run the program or what you can or cannot do with it. Freedom 1 is the freedom to study how the program works and adapt it to your needs. So this happens almost every day, which is that you can look at the source code for R itself, you can make changes to it if you want, you can improve it or make a better version of it. You can sell changes to it if you want. You can modify the program any way you want and adapt it to your needs. Of course, so you can look at the source code for this to get freedom 1. Freedom 2 is that you have the freedom to redistribute copies, so you can help your neighbor. And so the idea is that you can give copies to other people, you can sell copies, you can do whatever you want with it. And lastly, you have the freedom to improve the program and release your improvements to the public so the whole community benefits. So this is freedom 3, and the idea is that when people make changes to the program, they can release them to the public so that everyone gets those changes. And so these basic freedoms are outlined by the Free Software Foundation. You can see more about it at their website there. So there are a couple drawbacks of R. I won't go through all of them, and probably other people have many other complaints. But there's some basic drawbacks, which are, one is that it's essentially based on 40-year-old technology. So the original S language was developed in the 70s, was based on a couple of principles, and the basic ideas have not changed too much since then. And so as one of the results of that, for example, is that there's little built-in support for dynamic or 3D graphics. But things have improved greatly on that front since the old days, and there's a lot of interesting tools now and packages for doing dynamic and 3D graphics. Another drawback of R that I hear a lot about is that the functionality is based on consumer demand and basically user contributions. So if no one feels like implementing your favorite method, then that's your job to do. And so you can't, there's no corporation, there's no company that you can complain to, there's no helpline that you can call to say that to demand a specific implementation or a specific feature. If the feature's not there, then you have to build it. Or at least you can pay someone to build it. Another drawback, which is a little bit more technical, is that the objects that you manipulate in R have to be stored in the physical memory of the computer. And so if the object is bigger than the physical memory of the computer, then you can't load it into memory, and then therefore you can't do something in R with that object. So there have been a lot of advancements to deal with this too, both in the R language, and also just in the hardware side, there are computers now that you can buy with tremendous amounts of memory, and so some of those problems have been resolved just by kind of improvements in technology. But nevertheless, as we enter the kind of big data era, where you have larger and larger data sets, the model of loading objects into physical memory can be a limitation. And finally, I'll just say that R is not ideal for all possible situations. And so many people, I think, in a way, this is a good thing. They have very high expectations for R. They expect it to be able to do everything, but it doesn't do everything. And so you should go into this knowing that fact. So the basic R system is divided into we can think of two conceptual parts. There's the base R system that you download from a CRAN, which is the Comprehensive R Archive Network, and that's kind of the go-to place for all things R. And then there's kind of everything else. And so the base system contains what's called the base package, which has all the kind of low-level fundamental functions that you need to run the R system. And then there are other packages contained in the base system, which includes, for example, utils, stats, datasets, graphics, and a bunch of other packages that are kind of fundamental packages that more or less everyone might use. And then there are a series of recommended packages, so boot for bootstrap, class for classification, cluster, code tools, foreign, and a variety of other packages. These are commonly used packages. They may not be critical packages, but they're commonly used by many people. So all of these packages come with the base R system that you download from CRAN. Now, but there's much more than this, obviously, and on CRAN right now there are about 4,000 packages that have been developed by users and programmers all around the world. These packages are user contributed. They're not controlled by the R core. And they are uploaded to CRAN every day on a periodic basis. And CRAN has a number of restrictions and standards that have to be met in order to get a package onto CRAN. So one of the nice things about CRAN is that the packages that you download have to meet a certain level of quality. And so there has to be, for example, there has to be documentation for all of the functions that are in the package, and they have to make sure that they pass a certain number of tests. So CRAN has a lot of different packages written by users, and the number is really increasing every day. So it's very exciting to see all these packages on CRAN and to see new ones come up every day. There are also packages associated with the Bioconductor project, which is a project designed to implement R software for kind of genomic and kind of biological data analysis. And of course, there are also other packages that people make available on their personal websites, and there's really no reliable way to keep track of how many packages are available in this fashion. So there's really thousands of packages out there written by people that you can discover and use to analyze data. So there are a couple of documents that you can find on the R website as you're learning to use R. You may want to flip through some of these. One is an introduction to R, which is a relatively long PDF document now that kind of goes through the basics of how to use R, how to use the language. There's the Writing R Extensions manual, which is really only useful to read if you're thinking of developing R packages, which are these extensions to the main R system. The R Data Import and Export manual, which is useful for getting data into R in the various different ways. The R Installation and Administration manual is mostly useful if you want to build R from the source code, and I'll talk about that in another video. And then the R Internals manual is a really technical document for how R is designed, how R is implemented at a very low level, and it's not really for the faint of heart. But if you're that kind of a person who wants to know how R works at a very, very low level, this is the document for you. So I'm just going to end here with a couple of texts that are kind of standard or classic texts in this area. Of course, the books by John Chambers, Software for Data Analysis and Programming with Data, both published by Springer. And then there's two books by Bill Venables and Brian Ripley. One is called Modern Applied Statistics with S, and another one's called S Programming. Although they have they talk about S in the title, these books are both very relevant for R programming too. There's a book by Pinheiro and Bates, which is Mixed Effects Models in S and S+. That's also quite useful for R programmers too. And finally, Paul Morell, who designed the R graphics system, has written a book called R Graphics, and actually it's currently in its second edition right now. So a couple other resources. One is that Springer, the publisher Springer, has a series of books called Use R, which is a lot of very kind of relatively short books on how to use R for different types of topics, different application areas. And this is quite a nice series of books that you may be interested in. And there may be a book written for your particular area of application. And there's a longer list of books on the R website. So that was a brief overview of R and the history of how it kind of came to be. And starting with the next video, I'll start talking about the details of the R programming language and how we can use it to analyze data.